Hello Tuesday kids. So we're going to work on our periodic table information sheet. I'm going to go through and read the whole thing. So if you want to fast forward to the part that you need, you're more than welcome to do that. But I just want you to pay attention to each group and some of the things that we underline that might be unique to that group. That's really what I want you to get out of this video. All right. So we're going to put our name at the top. This is our Tuesday group. And I'm going to start reading. The periodic table is a list of all the known elements. It is organized by increasing atomic number. There are two main groups on the periodic table, metals and nonmetals. The left side of the table contains the metals with the greatest metallic properties. As you move from left to right, the elements become less metallic, with the far right side of the table consisting of the nonmetals. The elements in the middle of the table are called transition elements because their properties change from metallic to non-metallic properties. So sometimes you have elements that are a little bit of both. Okay, so we're going to get into what that means. So a small group whose members touch the zigzag line between the metals and nonmetals are called metalloids. So I'm going to circle touch the zigzag line and metalloids. That's our connection. The table is also arranged in vertical columns called groups or families. So vertical groups or families. And horizontal rows called periods. Each arrangement is significant. The elements in each vertical column or group have similar properties. The elements in each group have the same number of valence electrons, which determines the element's chemical properties, including reactivity. The valence electrons are the electrons in the outermost energy level. We've been studying that. So valence are the outer electrons. There are 18 groups or columns on the periodic table. All right, so let's get into each group. Hydrogen group. This element does not match the properties of any other group, so it stands alone. It is placed above group 1, but it is not part of that group. It is all very reactive, colorless, odorless gas at room temperature. Hydrogen only has one valence electron. One valence electron. So these would be very significant for your Friday quiz. So pay attention to these unique properties. Group 2. Oh, wait, second one, but it's still group 1, alkali metals. These metals are extremely reactive. We will watch a video in class of sodium in water. These will all have one valence electron. They are shiny and silver in color. Their density is extremely low, so they are soft enough to be cut with a knife. You could see them in that video with sodium. They were cutting that sodium with a knife, and it was falling apart in their hands. Group 2, alkaline earth metal. Group 2 has a two-part name. These are slightly less reactive than group 1. They have two valence electrons, and they are silver in color, but they are denser and more thick feeling than alkali metals. So the thing to remember here is that they're slightly less reactive than their group 1 neighbors. All right, group 3 through 12, these are the short ones, transition metals. These have a moderate range of reactivity, so these are all going to be different. But let's look right here. In general, they are shiny and good conductors. So that's what we will remember about transition metals. And then their valence electrons get tricky, so we leave those alone in middle school. Lanthanides and actinides, these are the ones at the bottom. These are also transition metals that were taken out and placed at the bottom of the table so that the table wouldn't be so wide. The elements in each of these two periods share many properties. The lanthanides are shiny and reactive. The actinides are all radioactive and are therefore unstable. So actinides are radioactive. The boron group, one metalloid and four metals, they are reactive and they have three valence electrons. Carbon group, 4 valence electrons. Nitrogen group, how many do you think they're going to have? 5 valence electrons. Oxygen group, they have 6 valence electrons. That's what we'll know about those. And these all vary in how many metals, nonmetals, and metalloids, because this is where you start to get into the zigzag line. So you have different amounts of metals and nonmetals, so their reactivity is different. Okay, group 17. All right, these are called halogens, and they are all nonmetals. They're very reactive, and they're poor conductors. So they're very reactive, and they're poor conductors. And they tend to form salt with metals. So this is where we get table salt from. So if we get here where this staple is, you can see the word forms salts. And the last group on the far right are the noble gases. These are the cool ones. I call these the nons. They're non-reactive, non-color, and non-odor. So they're colorless, odorless gases, and they are unreactive. They are also going to have 8 valence electrons. I forgot to circle my 7 right here, so go back up and circle that one too. All right, so now let's look. We have a periodic table that I tore apart. If you want to tear yours apart, that's fine. And let's follow our rules right here. We're going to color all the metals blue, nonmetals yellow, and metalloids green. Let's start with metalloids. So if my metalloids are going to be green, I'm going to come to the zigzag line, and I'm going to trace my zigzag line with the green. And we know that anything touching the zigzag line is going to be a metalloid, except for aluminum, because we know aluminum is a metal. So boron. You guys color yours better than I'm coloring mine. Okay, so those are our metalloids. We'll go back to our paper. We want to color the metals blue. So what happens when we get right here with hydrogen though? Don't forget, we have to leave him blank. We'll color him in a minute. All right, so that's what yours will look like with all your metals blue. So we made all of our metals be blue, and we want our nonmetals to be yellow. So let's make our nonmetals yellow. I'm just making my answer key here so it's easy for me to go find. So nonmetals, let's start over here with hydrogen. I always want to forget hydrogen is there. That's a nonmetal. And then we'll start with carbon. All right, so there's our periodic table really quickly. And then it wants us to for part 2. So we've done part 1. Part 2, highlight the group number above each column in pink. So I'm going to grab my pink, and I want the group number above each column. So that means I'm going to go vertical. So that means I'm looking at all of these numbers. So I'm going to go 1. So those are our groups. Then it wants us to number each row or period 1 to 7. Why don't we just highlight that in pink since they're already numbered? So we'll just come right down the side. I'm going to highlight those in pink since they're already numbered for us. So those are our rows. All right, I'm going to help you guys do part 3, and then I'll let you finish this on your own. So let's go right here for part 3. We want to, underneath each group, write the number of valence electrons. So what I want you guys to do is to give me a Lewis dot diagram. Think about your video we've watched and the note cards we made. We're going to make a Lewis dot diagram for each group, but we're going to skip rows 3 through 12, columns 3 through 12. So back to our periodic table, let's go make a Lewis dot diagram. So if we go right here, you know, I'm going to go across the top too instead of the bottom. We're just breaking all the rules. So here's hydrogen. How many valence electrons will it have? Well, it's in group 1, so it will have 1 across the top. If I go too fast, you can pause it. Group 2, since it's group 2, it's going to have 2 valence electrons. And then we skip the short ones, the transition metals, and we start right here with boron. We're going to call this our 3rd group. So boron will have 3 valence electrons. Carbon will be 4. Nitrogen will be 5. Oxygen will have 6. Careful with your dots that they don't start to run together. And then these are our halogens with fluorine, F. 1, 2, 3, 4, 5, 6, 7. So I have 2 on the top, 2 on the bottom, if you can't see that, and 2 on the side, and then 1 over here. So this group only needs 1 more valence electron. So we're going to do 2 right here. Let's do helium. Because the thing with this group is that its outer shells are full. But how many does helium need to have a full outer shell? Helium needs 2. How many will neon need for a full outer shell? It's going to need 8. 1, 2, 3, 4, 5, 6, 7, 8. So just so that you know, helium is full with 2 because its first parking lot is full. Remember those parking lots. You can park 2 electrons in the first parking level. You can park 8 electrons on the next level, and you can park 8 electrons on the level after that. So that makes helium be full with 2. And another example is neon being full with 8, and all the way down those are going to be full. Okay, from here on, you guys can finish your worksheet.